Good morning, everybody. Today is April 9th, and we are going to be covering the second day of 13-5. So we'll just call it 13-5 Day 2. Now, yesterday we focused more on the graphing of coordinates in space. So we looked at coordinates that had x's, y's, and z's. Today we're going to focus on some formulas. The first of which is the distance formula. Now, you know the distance formula very well. We've used it all year. What we're going to do today is take what you know and transfer it to the three-dimensional coordinate system. So if I have two coordinates, x1, y1, z1, and x2, y2, z2, the distance formula looks like this. x2 minus x1 squared plus y2 minus y1 squared. That's exactly what you know, only now we just need to account for the z's. So z2 minus z1 squared. Okay, so the distance formula is really the same. We're just now including the z coordinates. So for example, if we want to find the distance between the point 4, 0, 0 and -2, 3, -1, we can just plug that into our distance formula with three dimensions or three sets of coordinates. So here we go. -2 minus 4, those are the x's, plus 3 minus 0, those are the y's, plus -1 minus 0, those are the z's. Okay, and then we just simplify like we have before. This becomes -2 squared, this one becomes 3 squared, and this one becomes -1 squared. Simplify again. So it looks like we have 4 plus 9 plus 1. So that would be the square root of 14. As a decimal, that would be maybe about 3.7 or 3.8, something in that neighborhood. Okay, so that's how the distance formula works in three dimensions. The next one we're going to take a look at is the midpoint formula. Now again, you know what the midpoint formula is in two dimensions. Okay, so I'm going to start out the same. We have 2 points, x2, or x1, y1, excuse me, x1, y1, z1, and x2, y2, z2. The midpoint, we take the x's and add them together, divide by 2. Then we take the y's, add them together and divide by 2. That's the one that you know. Only now we're just going to continue on with the z's. Add them together, divide by 2. Okay? So, an example of this one with numbers. Find the midpoint between, and you know what, I'll even use the exact same ones that I had before. 4, 0, 0, and -2, 3, -1. Okay? So midpoint, we are going to add the x's. 4 plus -2, then divide that by 2. We're going to add the y's. 0 plus 3, divide that by 2. Add the z's. 0 plus -1, divide that by 2. If we simplify just a little bit, we have 2 over 2, which will eventually give us 1. Then we have 3 over 2, which will eventually give us 1.5. And then we have negative 1 over 2, which will eventually give us a negative 0.5. Okay, simplify one last time. You can certainly write them in decimal. That's perfectly fine with me. So perhaps it might look like that. If you prefer to leave them in fraction, that's okay too. Okay, so that's the second formula. The third and final formula that we're going to take a look at is the formula for a sphere. Okay, so here's how this one looks. A sphere with center H, K, J, and radius R is represented by the equation x minus h squared plus y minus k squared plus z minus j squared equals r squared. Now what you may notice is like this part in these parentheses, it's kind of similar to what we saw in that vertex form, like the x minus h, only the h and the k there represented the vertex, whereas here the h and the k and then of course the j represent the center of our sphere. Okay? So I'm actually going to do two examples here. Let's write an equation for a sphere with a center at negative 1, 2, 5 and a radius of 4. Okay? So for this one, this is the h, this is the k, this is the j. So it looks like it's going to be this, x plus 1, because it's a minus negative, right, because it's minus h, plus y minus 2 squared plus z minus 5 squared equals r squared, so we would actually write 16, not 4 squared, just 16. Okay, so that's the first one that I wanted to show you. That's a pretty basic one. The last one that I want to show you is one that looks like this. This one's going to be a little bit more challenging. Write an equation for a sphere with center at 0, 2, 1 and a point on the sphere at, oops, not negative, how about positive? Positive 1, comma, negative 1, comma, 3. Okay, so this one's going to be a little bit different because we don't have the radius. All right, so I'm just going to rewrite the formula from the previous page. You already have this written down. Okay, so what we do know is the center. This is h, this is k, this is j. We know that. We also have a random point on the sphere. Well, that's going to be represented as just an x, a y, and a z. So you know what? Let's plug in what we know, and we should be able to solve for r. Watch. We have an x coordinate as 1, and then our h coordinate is 0. We have a y coordinate of negative 1, and then our k, oops, not a comma, I want a minus is what I wanted to write, minus our k, which is 2, and then we have a z coordinate of 3 and an h coordinate of 1. Okay, so if we simplify this, we have 1 squared plus negative 3 squared plus 2 squared. So that's like saying 1 plus 9 plus 4. So it looks like we have 14 equals r squared. And you know what? I'm just going to leave it as r squared because in my final answer I want it written as r squared. So now I'm done with this point. I've already used it. So now I want to use my center in my final answer because it says write an equation. Okay, so I'm going to go x minus 0 squared. Now of course you could also just say x squared if you don't want to write the 0. X minus 0 squared plus y minus 2 squared plus z minus 1 squared equals r squared, which is 14. That's your answer. Okay, now as I was saying, if you don't want to write this as x minus 0, you could just say x squared plus y minus 2 squared plus z minus 1 squared equals 14. That's another way of writing the same thing if you so choose. And that's it. That's the last part. So right now you can use the rest of the time to work on your worksheet, and I will see you guys tomorrow. Have a great day.